So 7b, wasn't it? Minus 8, minus 13, minus 18, all the way to minus 308. Okay. So firstly, we should write down what the A and the D are. So what does A equal?
Minus 8.
Minus 8. And D?
Minus 5.
Minus 5. Come on, Joseph. Now we don't know what the n is, and the way to find the n is by making the last term equal to u. And we have a formula for u. What is it? It's A plus n minus 1 d. No, stop talking now, come on. Minus 308 equals minus 8 minus 5n plus 5. So it's that minus 3 becomes a plus 3. Minus 305 equals minus 5n, which is n equals 61. Is that right? So, let me change the colour of that to red. So you get n equals 61. And that's it. So, yes?
305.
Yeah. That, and bring those two over to it. Minus 308 plus 8 minus 5. Okay, so the sum would be n over 2, 2a plus n minus 1 times d. So what's that going to be? 61 over 2, that's minus 316. But then I can divide 2 into that. 158 minus 158 times 61. So minus 158 times 61. What's that? Minus 158 times 61. Yes?
Since stuff are obviously going to get complicated in the exam, what is like how do we exactly
If you
know
Wait.
the
Yes.
formula and the S?
In the formula book you get both formulas.
Yeah, but like, okay, depends on what's given. We use
It depends entirely on what's given and what's asked for. So here I'm asking for a sum, if you look at the question. So I'm looking for a S formula. Now what is the total? What is it? I can't hear you.
Minus 9638.
Thank you. Yeah. Okay. Yes.
If you bring minus 3 to it will be plus.
Where? Here? Are we talking about this line, yeah? So, minus 8 comes over here to make plus. Minus 308 plus 8 is minus 300. And then if I bring this over here, minus 300 minus 5 is minus 305.
is it 6 and 8 that you cancel?
6 and 8? Where?
You
Here?
said that like yesterday, don't do 6 and 8.
6 and 9.
6. No, it was 6 and 8. Wasn't it? No, 6 and 9. Yeah, 6 and 9. Yeah.
So from where we get minus 16 and 16
This is 2a.
and this one?
N minus 1d. Okay, I'm going to move on now. So I'll do, what did I say? 8i, wasn't it? Yeah. So I tell you that the sum of the first 14 numbers equals minus 224. And I also tell you that the 25th number equals minus 29. So here I use my formula. N over 2. What's n over 2 here? Yeah, which is 7. 2a, I don't know. n minus 1,
13.
13, d. And then this formula here is a plus n minus 1 d. What should that equal? Minus 29. Now, does 7 go into 224? I think this is where I didn't... Exactly, does it? Yes? You really need to stop being so dramatic. It's really distracting me. Did I make a mistake? So why are you being so dramatic? That's the only reason to be dramatic, is if I make a mistake. If you make a mistake, that's okay. It's expected. You're students. Okay?
Where did you get the 7?
N over 2. Okay. Sadiq, it goes in here.
Minus 32.
What is it?
Minus 32.
Minus 32. And I get 2a plus 13d equals minus 32. And I'll multiply this by 2. 2a plus 48d equal minus 58. Wait! Do I need to continue?
No.
Why do you know that I have to minus it by 2?
Minus it by 2?
Times it by 2.
Oh, because I want to make the 2 a's cancel. I was going to cancel the a's here. I'm doing simultaneous equations, 2 equations. Do I need to continue to find a and d? Alright. So if I subtract 2a minus 2a, it's gone. 13 minus 48 is minus 35d, is it? And then minus 32 minus 58. Okay, so you have d equals 20 minus 26 over 35, and then a you can get by plugging d back into this. Did anybody get it yet? It would be minus 32 minus 13 times d, which is minus 26 over 35, all over 2. I just put this back in here and then got out the a. Yes, Sadiq, tell me please, what's the a here? That's 32. What is it? Minus. Thank you. Right, so that's the A and the D. Okay. Too slow? There. Go down? Okay, we'll start the new lesson then. Last lesson was called arithmetic sequence, and this one you might know is geometric. So what do you think would be special about geometric sequence? Multiplying, whereas arithmetic is addition, adding. So let's have a look. So as an example, I start off with the number 3 and I multiply it by 2, 6 multiplied by 2, 12, 24, and so on. So what I'm doing each time is multiplying by 2. Can you see that? Yes, you see that?
Which is D?
Not quite D. Well, it's the same role as D, but we give it a different letter. So, like before, I'll call the first term A, and the multiplying term I'll call OR. The ratio term, or common ratio. So in this example, what is A? 3, and OR? 2. Just like the last lesson, we have two formulas to find. The first formula is U, and the second formula is S. So let's look at the U first. So if I start off with first term, what letter would that be? A. And then I multiply by OR, so what's the next term? AR. And the next term? Yeah, AR squared, AR cubed, AR power 4, power 5, power 6, and so on. So, looking at this, who thinks they can give me the formula for UN? UN equals AR n minus 1. So we're already ready to do our first example. Let's take the sequence I gave you at the start, and that's first, second, third, fourth. Let's find the 10th term. So what letter would that be? U 10, yeah? Equals A, what's A? Or, what's or? 2, and n minus 1? 9. 2, 4, 8, 16, 30, 2, 4, 8, 16, 32, 64, 3072? What is it? I was way off. What is it?
1536.
Okay. So that's the 10th term. And let's find a formula for the nth term. So UN, what would that equal as example? A, which what's A in my example I'm using? 3, and or 2, and n minus 1 is just n minus 1. So, you know, that's it. But you can clean this up a little bit. And we'll look at this a bit more in the next chapter. But all you need to know for today, and some people might know this already, 2n minus 1 is equal to 2n divided by 2.
Yeah.
Okay? So, now don't worry if you don't know that, if you haven't seen it before, that's okay. The next chapter is all about this. But just for today, the only thing you need to know is 2n minus 1 is equal to 2n over 2. Okay? So if I use that in here, I have 3 over 2 times 2n. What I did was I changed this into that, 2n over 2. So there it is there. See, 2n over 2. And I kept the 3 just in front. In fact, you can stop here if you want. It's just the answer at the back might be like this. But both answers are perfectly fine. So you didn't need to do this. Hassan, yes?
Maybe to get 10.
Huh?
Somewhere you get 10.
10? Oh, that's just my example. What is the 10th term? Yeah. So it's like I've done question 1 and question 2 in the workbook. Now, another example. Suppose I have take my example again. What did I start with? Was it 3, wasn't it? 3, 6, 12, 24. Isn't that right?
Yeah.
Dot, dot, dot. 96. So just like the last lesson, I want to know how many terms there are. Would somebody poke Brendan? It looks like he's falling asleep. No, you come on. Stay focused now. Just like the last lesson, I want to know how many terms there are. So what do I do to find out how many terms there are?
Use formula.
Yeah, make u equal to the last one. So I make u equal to the last one. Now what's the formula for u here? A, come on, or n minus 1 equals 96. Okay. Now, what's A here? 3. And what's or? 2. So what you need to do next is bring the 3 under firstly. Okay. 96 divided by 3 is 32. Now, you may need your calculator here, but for the people who are awake, 32 is 2 to what power? Very good, 5. 32 is 2 power 5. So, what you have here is 2 power this equals 2 power this. 2 power 5 is 32. 2, 4, 8, 16, 32. You can check it on your calculator. 2 power 5 is 32.
2 power 6.
Is 64. Yeah.
2 power 7.
And so on and so on. Yes. Okay. So n minus 1 equals 5. So n equals 6. No. I'm hearing way too much talking onto the left side of me here, please.
So if we don't have like the 2 thing, okay? The 2 is
This
not,
2 here?
No, down.
This one?
Yeah. If the 2 is not a common, for example, if we have
That's a problem if it's not. Yeah, like for example, if that was 9, then that would be 3 squared, you know. You're right. You need these to be the same.
like if we didn't
Now, you see, I made this lesson in such a way that it should be the same. But of course, in the exam, it doesn't need to be the same. And if it's not the same, what you need to do is something that you'll learn about in the next chapter. It uses something called logs. But we're not doing logs until the next chapter. So I made these questions in such a way that the answer is going to be like this. So the reason I put 2 here is because in the previous line it's a 2 with a power. So that's where that 2 came from. Go up to the start of the question. There you go. Yeah? Okay. Okay. So basically I've done questions a lot like number 1, 2 and 3. I'm going to do an example from number 4 and then we're going to look at the sum formula. So I'll do 4a here. No, I'll do 4c. Let's be different. 4c. The third term is 2 and the sixth term is minus 2. And I want the A and the OR. Just like in the last lesson, you have 2 unknowns, A and OR. And you can make 2 equations from U3 and U6. So firstly, U3, what's that? A or power 2. Yeah, A or squared. That should equal 2. And then this one here? A or 5 equals minus 2. Now please listen carefully. Unlike the last lesson, the way you solve these problems is completely different. What you do is you write the bigger one on top of the smaller one. So you're at A or 5 equals minus 2, and you've got A or squared equals 2. And then what you need to do is divide both equations. So I take A or 5 and divide it by A or squared, and I take minus 2 and I divide it by 2.
put the bigger number above the
Yeah, put the bigger power above the smaller power. Now, yes?
Or are you doing minus 1?
Well, hang on. Firstly, the A's cancel.
R3.
Yes, it'll be R3, but I'll explain why now for those who don't know. Minus 2 divided by 2? Minus 1, okay. And then if you want, you're left with R5 over R squared equals minus 1. And if you want, R5 is like 1, 2, 3, 4, 5 R's. And R squared is 2 R's. Right? Yes? So, cancel, cancel. So what am I left with? Yeah, R power 3 equals minus 1. Now you can take out your calculator, and if you do cube root minus 1, well, no surprises, what will the R equal? Minus 1.
There is an equation of power divided, which 5 minus 2.
Yep, that's right. Yeah, you're right. It's just going to be 5 minus 2.
It's wrong.
It's a rule, and that's next chapter. But you can use it if you know it. That's fine. If you know the rules for powers, you can use them. Wait 1 second. Faisal, yes?
How did you divide both sides in different numbers that they're still equal?
Yes, I was hoping somebody might be worried about that. So I'll give you an example to show you how it works, okay? I'll just put it in blue here. I want to use numbers so it's a bit clearer. Yeah, so let's take something like 4 equals 2 plus 2. I think we're all happy with that. No, I need to have it as multiplying, sorry. So 4 equals 2 times 2. And let's say 10 equals, I should put the bigger one on top. 4 equals 2 times 2, and 10 equals 5 times 2. Now if I divide, I get 10 divided by 4 is 10 over 4. What's 10 over 4? 5 over 2. 5 divided by 2 is 5 over 2. And then 2 divided by 2 is 1. So you see, if you have two equations that are true, and if you divide them, the result is still true. You know from chapter 1, if you have two equations, you're allowed to add them together, true? Yes? And you're also allowed to subtract. Now I'm telling you, you're also allowed to multiply and divide them. And the dividing is what's required here. Now I'm not quite finished yet, because what do I still need to find? A. So what's the easiest equation? I think this one here, AR squared equals 2. So I have AR squared equals 2. What's minus 1 squared? 1, yeah. A times 1? A. So I just get A equals 2. If I put that in there. Yes, one more time from the top. R equals minus 1. I put that in here. What's minus 1 squared? 1. A times 1? A times 1, come on. A. So A equals 2. Yes.
One more thing, when we have something like R squared equals minus 1.
Yes, that's a big problem, because you can't take square root of minus 1. So again, I should have made the questions in such a way that that should not happen. Yes. But you're right, it's okay here because it was cube root. It shouldn't happen for square root. Is that okay? Yes? So what I've done for you now is like questions 1 to 4. Now we'll have a look at the sum formula when you want to add all of these together. Okay. So, what would the sum be? What's the first term? A plus AR plus AR squared all the way until
AR is about n minus 1.
Yes, n minus 1. Now, the last time, the way we made a formula here was doing a little trick by putting the first with the last. Do you remember? The trick here is I write down Sn again, but the trick is not to reverse the order, but instead to multiply by or.